Welcome learners. In today's lesson, today we're going to look at introduction to structured programming. We shall start by defining some basic terms. The first term is program. So program basically is sets of instructions that enable or guide the hardware on how to perform a given task. So a program is same as knowledge that a human being can use in order to perform a given task, because if you are seeing a dangerous animal like a lion using your eyes, you cannot interpret that that is a dangerous animal. You need to run away if you lack knowledge. So the same, a computer has the physical features, those ones that we can see and touch, that known as hardware, and those hardware components cannot work or cannot solve a problem without being given knowledge. So knowledge in a computer is known as programs, which is some software, and we are saying it will guide, it has a step that now the hardware will follow in coming up with a solution to a given problem or in performing a given task. Another term is programming. So program basically is a process or the process of coming up with what we call computer programs. Another terminology is programmer. So programmer is a person who writes or comes up with computer programs. Then number 4 is programming paradigm. So programming paradigm is a style of creating computer programs. Programming paradigm is a style of creating computer programs. So another terminology is programming language. So programming language are different environments that enables people known as programmers in communicating with the computer so that they can guide that computer in solving a given problem. You as a human being, how can you communicate with a machine? How can you communicate with a device and give that device a formula which the device can use in solving a given problem? You need a language. So those different languages or environments that programmers use in guiding computers to perform a given task known as programming languages. There are different classes of programming languages. Number 1 is machine programming language. So in machine programming language, programs are written in zeros and ones, which is a language that a computer can understand. The language is binary language. So such a program doesn't require translation. But if a human being is given such a program, it's very difficult to read through and understand such a program. Now, machine language programs are machine dependent. They depend on the architecture of a given computer. So if I write a given program in machine language on one computer, once I transfer that program to a different computer, that computer cannot understand and execute that given program. I have to modify, perform some changes on that program so that now the computer can also execute. So we are saying it will depend on the architecture of the computer, and the architecture of the computer is basically defined in terms of the processor manufacturer. Then we can look at the second class of programming language known as assembly language or low-level languages or second generation languages. Low-level languages, assembly language, or second generation language. Here programs are written in what we call the normal English like vocabularies to represent the operational part of a program and the operand. So a program has two components. One is the operational part, another component is the operand part. So the operational part of a program will guide the hardware on what to do with the data. If let's say I want to come up with a program to add two numbers, so there's one part of that program that will be basing on the operational part. So the operational part will guide the hardware on how to add the two numbers. Then the operand part guides the hardware on the data part, where the data part or data are stored. So basically the two numbers is in terms of the operand part. So we are saying in low-level languages or in assembly languages, the operational part of a program are written using mnemonics. So a mnemonic is basically a certain keyword that has a predefined meaning and a reserved function. An example is add. So if you want to add two numbers, the operation is adding. So I say add as a mnemonic. If you want to multiply two or more numbers, it means I'm performing that operation of multiplying. The mnemonic there is mult, M-U-L-T. If you want to divide numbers, I say div. So we are saying programs are written using the normal English vocabularies to represent the operand part of a program, and they are written using what we call mnemonics, which are certain predefined words that have a predefined meaning and function to represent the operational part of a program. Now, programs written in low-level languages must be converted in machine language for the computer to understand and execute. So we have another program known as an assembler that converts low-level language instructions into machine language so that the computer can understand and execute. That third language is known as high-level languages or third generation languages. High-level languages or third generation languages. Basically, these are programming languages that uses the normal English, the natural language, in coming up with a program. If I'm a programmer and I want to form a program using human high level, I am forming those programs based on the human natural language. The programmer basically uses the human natural language in coming up with programs. So it means if you are given a human being such a program, the human being will easily understand each and every line that the programmer has formed. But for the computer to understand, those programs must be converted from high level to machine language. So we say low level languages uses an assembler. Now with high level languages, it uses two programs. One is a compiler, another is known as an interpreter. So a compiler will convert all the instructions or lines written in high level to machine language at once. Interpreter will convert one line at a time, line by line. So basically, if I form a program which has 10 lines in high level, once I'm using a compiler, it will convert all the 10 lines into zeros and ones. If I'm using an interpreter, it will convert line at a time, one line at a time. So at the end of the time, at the end of the day, I will have 10 files which are in zeros and ones, and are the equivalent of high level instructions that are formed in what we call high level. So basically, with interpreters, we need another program known as a linker, and a linker basically will go and take the separately translated instructions which are in zeros and ones to form one complete file. It will combine them to form one complete file. So any program instruction written in high level in a language that a human being can somehow understand, we call it source code. So source code are language instructions written in high level where a human being can somehow understand. Now object code is a translated instruction which are in zeros and ones that a machine cannot understand. If I translate the high level instructions into machine language, they will be in zeros and ones, and those instructions are referred to as object code. Then the fourth programming language is known as fourth generation language. Fourth generation language is basically a language that enables programmers to create online applications, and these applications run on the internet via what you call web browsers. They run on the internet via web browsers. One function of those programs, one is for formatting. If let's say I have what you call an account in Facebook. So Facebook is an example of an application that runs on the internet to enable people to communicate. So whoever came up with Facebook as a software or a program, he or she used what we call fourth generation languages to come up with it. So with fourth generation languages, one, we are using it for formatting. How that data, once I create account in Facebook, it means I'm providing my details to be stored on a central point on a machine known as a server. Now any machine I'm using to log into my account, we call it a client. So the server and the client must communicate. So with fourth generation languages, we create what we call interfaces. Interfaces are point of interaction, enabling users to interact with data remotely. You are seated in Kenya, and let's say the machine that is storing your account details for Facebook is in USA, but you are interacting with that given data from that given machine via the interface. So for you to interact, we must have the internet. So internet means the physical connection of computers. For the computer in Kenya to communicate with that computer in USA, they must be physically connected. That is internet. For you to access that resource, we must have what we call the WWW. The World Wide Web is a service that runs on the internet, or a program that runs on the internet to give users universal access to resources. So we are saying fourth generation languages provide what we call access to online resources, enabling programmers to come up with online applications that run on the internet. Then last, you have what we call fifth generation of languages. Fifth generation of languages are still in a state of development, but some are being applied in a field known as artificial intelligence by coming up with programs that guide hardwares like robots in performing tasks that are dangerous to human life. For example, if I come up with a task of, let's say, doing a research and finding out what happens at the sun, I can create a device that performs a given task. So I can program, because the device will be in terms of hardware, so I can program it and give it what you call information instructions in terms of knowledge which it will use to perform the given research. So that marks the end of our lesson today. Thank you.